Hello, welcome to Explorer Classroom. My name is Kip Hotman. I work at National Geographic Society in Washington, D.C., and I will be your host today. And I am so glad that you are joining us. At National Geographic, we believe that anyone can be an explorer and that you have the power to make a difference in the world, no matter how old you are. Explorer Classroom is here to inspire you with stories from the field and connect you with our explorers live to answer your questions. Before we get into today's lesson, I'd like to welcome all of the classes who are joining us today, especially Carlsbad, Colegio Preparatorio, and Kaiserslautern Middle Schools, Atlantic and Hillsborough High Schools, Yadkin Valley Regional Career Academy, EBS Anadia, St. Margaret Mary School, Fulton and Alsbury Academy Arts English, Redwood Cooperative School, and North Carolina Global Academy. And a special shout out to all the classrooms joining from the National Geographic Learning Network. We are so excited to have you all here today. And today, our explorer is Louise Leakey. Louise is a paleoanthropologist. She studies fossils to uncover the story of our past. She conducts riveting research in field expeditions in the rugged terrain of northern Kenya. And today, she's inviting us on an adventure to learn about her work and how she finds hominid fossils in the field. Louise will be joining us live soon, but first, she will be taking us into the field for a look at where she does her research in Africa. Now, let's connect to Louise in Lake Turkana.
Hello, everybody. It is great to join you on National Geographic Explorer Classroom from the field at Lake Turkana in northern Kenya. Northern Kenya is home to a very large desert lake. It's about 160 miles long. It takes me a whole hour to fly from the south end of the lake to the north end of the lake. And inland, either side of this enormous lake basin, this desert lake basin, are fossil sites that have been deposited between 4 and 1 million years ago. Those are the areas that I'm particularly interested in working in. And teams of fossil hunters walk over these hillsides looking for the remains of animals and human ancestors that lived in this region in past times. So this area is very, very hot, can be incredibly windy and sometimes really very dusty as well. And we really depend on the team of fossil hunters to help us look for all the little fragments of bone that erode out onto these rugged hillsides that are covered in sandstones and other sediments that were laid down by the lakes and rivers over the past 4 million years.
You just heard Louise mention that this area is a desert lake and that fossils in this area can be dated back as 4 million years ago. So I want to ask you, if you travel back in time 4 million years, what types of plants and animals do you think you will see living in the area that Louise is working in? Students, share your answers with your teachers. Shout it out. Let them know what you think. And teachers, type the answers that you hear your students share in your chat bar. And once again, the question is, if you travel back in time 4 million years, what types of plants and animals do you think you will see living in the area that Louise is working in? And teachers, I'll give you some time to type your students' answers into the chat bar, and we'll get back to this question here in a little bit. But in the meantime, I'm super excited to tell you that we have the pleasure of Louise joining us live online today. Let's say hi to Louise. Hi, Louise.
Hi, everybody. Shall I see you now? Yeah, I can see you. Hello, everybody. It's really nice to see you today. I can't wait to hear all your questions. And I'm actually in Nairobi and it's about 5 o'clock in the evening. I flew down from the lake, so I'm just here to join you today and to share some exciting stories from the field.
Well, we can't wait to hear these exciting stories, Louise, and it's such a pleasure. Thank you so much for joining us today. And I'm starting to see some answers pop up in the chat bar regarding the question that we asked earlier. What animals and plants do you think used to live in this area that Louise is conducting the excavation? And remember, we're talking about 4 million years ago here. So I'm going to share a few of the answers in the chat, Louise. And I'm seeing giant sloths, giant animals like primates, monkeys, mammoths. I'm also seeing some animals in the water too, sharks. And someone has dinosaurs, Tyrannosaurus Rex. And I see some of it I see in the zoo sometimes, lions and elephants and giraffes. But can you share a bit? Tell us what the researchers think this area was like back then.
So it's all these different fossils that we find there really helpful in trying to understand the habitat and the paleo environment of this area, what it looked like. And so we know we have these enormous crocodiles in the rivers and lakes. We've got saber-toothed cats at 4 million years. We've got very large elephants, several different species of elephants that lived there then. There's one which has these tusks that come out of its lower jaw called Dinosaurs. We have big snakes, we've got frogs and crabs. So there are obviously little rivers and streams in the area as well. We don't have any sharks because this is a salty saline lake rather than the ocean. But the crocodiles and hippos, they really are there in abundance. So it's actually, there's a lot going on. It's probably a lot more lush than the area that we see there today that you saw pictures of, this desert and this large lake in the desert. There were probably palm trees and reeds and grasses, and just a really wonderful place to live. And of course, there were some ancestors of ourselves, but they didn't look quite like we did. So I see Australopithecus there, and we'll talk a little bit more about that later. But yes, there were some other hominin, upright walking ancestors that lived on that landscape as well. Yep. So well done, everyone. It looks good.
Agreed. Well done, friends. Amazing answers. And I'm glad you were able to read that one for us, Louise. I saw that one and I was like, oh, I don't know about the pronunciation here. So thank you for that. And honestly, who would have guessed that a desert could be so lush, filled with life even back then? That's definitely not what I imagined. So I love the picture that you painted for myself and for the audience. So thank you for sharing that answer with us. And just curious, how do you know that these animals and plants used to live in the area? Is there a specific technology that you use to figure that out?
So the key is actually finding the fossils. So you've got to get out there, get your boots on the ground, and then walk over these hillsides and look. So the more eyes that you have looking for little fragments of fossil that are eroding out of the landscape, the better chance you have of finding something important. And when you find something, you need to know what it belongs to. So we actually sent a team of fossil hunters out walking over these hillsides. But can you imagine if we had more eyes helping us to look? And so what we've actually done in more recent years is actually fly a drone over the area so that we can then have more people looking through that imagery and trying to find things that we might have missed. So a drone's actually quite useful because you can get a view from above. And so it's very helpful when we want to map an excavation. So you see in this picture, there's actually an excavation that we've taken off the surface and exposed a whole trackway of footprints. And so we can use this image to map that site very, very easily. But before we had drones, I actually used to hang a camera off a kite, and then I'd have to walk over the hillsides trying to make sure that the camera was right above the site, and then hope that it would take enough pictures that one of them might have captured the image that I want. So it's a lot easier now that we've got drones. We can use that imagery and put it into citizen science projects. I did that a little while ago, and we're going to do it again. And we'll probably share that with you when we do it, so you can actually help us look through those images and help us find those fossils. So watch this space.
Oh, thank you so much for sharing. It's fascinating to me. I mean, who would have known that back before drones, you all were using kites to capture those images? But I'm definitely glad you all have the technology now, like drones, to make life a bit easier. So when you all see something of interest on the surface, what happens next? What's the process?
Okay, so when somebody finds a fossil, nowadays, everybody who's out looking has got a GPS, a global positioning system, that actually most people today have on their cell phones. And we used to have a GPS, and then we'd have a digital camera. And now actually you can do everything off an iPad. So whenever we find something, we need to mark where it is. You can't move a fossil, because if you move it, then it loses context. So once we find something, it's only then that we can actually then begin to excavate away the sediment. So you see in this picture, I'm carefully digging away the earth from around the top of a skull. And you've got to be very, very careful that the bone doesn't break, and you paint it with hardeners, and then you excavate layer by layer. And all of this sediment, the earth that's coming off from around the site, you put into these metal pans called karais. A karai is a Swahili word for a metal pan. And then that's poured into these screens, and you shake away all of the dust. And then you've got to look through all of that for tiny fragments of bone that might have got left behind. So it's as though we're putting tea leaves through a tea strainer, but you're actually looking for bits of bone. And once you've got all of those little fragments out, you have to sort through them carefully and wash the sediment again. And sometimes we do it twice. And then once you've got the little fragments, you've got to work out if they belong to the original fossil that you were digging out of the ground. And then if you're lucky, they actually fit on to the skull or whatever it was that we were digging out. And then you can actually make it look beautiful using air scribes and take away the sediment from the bone. And eventually you describe what it is and put it out into a publication so that other people around the world can see and use that data from that one fossil. But it can take years and years to find a skull of a human ancestor. Most of the things that we find are actually the bones of other animals that lived on this landscape. So we're always very busy digging things up, but very occasionally we're lucky enough to find the skull or a jaw or something of an ancestor that will help us to understand the story of us. So I hope that makes sense to you.
Yes, no, that's great to see that. And I really appreciate you sharing the clips, because, well, at least for myself, and I imagine for our audience too, a lot of people don't know the intentional work that happens. And like you said, how long it can take, years and years, to actually find like all the fragments or pieces of a skull or a fossil. So such amazing work that you and your team are doing out there. Thank you, Louise. It's super fascinating. And friends, now that you have learned how Louise and her team of fossil hunters find the fossils, Louise has a challenge and a fun game for you. Louise, could you tell us a little bit about how to play the fossil challenge?
Okay, so we've actually put together a few images here, and in the image there's a fossil, and it belongs to a different animal. And initially, let's just look at finding the fossil in the image, and I'll actually tell you what that fossil belongs to, if you like, and then eventually we'll come on to you trying to guess the fossil. So can you see the fossil in this image? It's actually somewhere in the center. And if we zoom out a little bit, you should be able to see how hard it is as you're walking over this landscape to spot that fossil. That's actually a row of hippo teeth. There's some molars of a hippo, and from the front to the back there's about 4 different teeth that are visible. So this is a hippo mandible. And as you zoom out even further, you can see it's a lot harder to spot it on the landscape. So that's the first one. And then we have another fossil here, which you need to look quite carefully at. We've actually been digging this one, so it's a little bit easier to see. And this fossil, if you can spot it, is, well, there's a lot of it there, you can see. And that actually belonged to a giant snake. And you can see some of the ribs in the front of that shaded image. And all of its vertebrae are sort of curled around on top of each other there. So that's a large snake, probably was a python or something like that. And it must have been a good 20 feet long or thereabouts. It was a huge snake. And who can spot the fossil in this image? There's a few rocks, but there are also a few bits of bone as well. I think you've got that. You can see those are the bits of fossil there, and they're ends of the long bone of an antelope. So you've got a bit of tibia, the lower leg bone of an antelope there, and some other bits of bone shaft as well. Here's a real challenge. See if you can spot the fossil in this image. You've got to look much more carefully. Anyone see it? Okay, here it is. There is a lower jaw there of a 4.1 million year old human ancestor as it was found. And then you can see, if you don't have your eyes looking very carefully, you might have missed that. But that's all the teeth of a lower jaw of a ancestor that was called Australopithecus annamensis, if you want to know the species name. So that's quite fun. So well done, everyone. Here's a fossil. I wonder if you can guess what this fossil belongs to. I'm going to let you guess it now. So you can type your answers in the chat if you like. Be a few more minutes and see. But it has very big teeth and a big toothy grin, and that's about 1 meter long. It's well, somebody said it's an alligator, but actually we don't have alligators. It is a crocodile. Well done, whoever guessed that. That's right. That's a crocodile. You see the sunglasses were on its nose for scale. Here is another animal. What do you think this animal is? It's got a very large tusk that's coming out of the top of its skull. Somebody said a mammoth. No, a cow would have horns of sort of round behind its ears. This is sort of around the front of its jaw. So this one is in fact, it's a pig, believe it or not. It's a pig skull. It's a funny looking pig, but you can see how things that lived in the past look so different from things that live today. They've changed in time, and we would never have known that animal existed if we hadn't found the tusk and skull of that thing. It's over 1 meter tall and had this giant tusk. So that's a pig skull. It's called Metridiocheirus. And what else do we have? There's another fossil. I wonder who can guess this one and see what you think that might belong to. It's sharp and pointy. It belongs on the top of someone's head. Any guesses on this one? It's an antler. That's sort of right. It actually does belong to an antelope, and it's a horn. It's a horn core. So this would have been an animal like a waterbuck or something like that on the landscape. A very pointy, sharp horn core. Okay. Let's see if we got, I think that's it. So well done, everybody. I think we've done really well, and you made some very good guesses there as well. But you can see how it's important to try and work out what other animals lived on this landscape. And so you find these fossils, and when you find them, you say, aha, right, because we got a crocodile here, there must have been a big river, or there must have been a big lake. So these animals are really important for understanding the habitat that our human ancestors lived alongside. Okay.
Louise, I have to say that was a ton of fun, and thank you so much. And I know that you're happy that I'm not with you on your site because I probably would have stepped all over those fossils. Looking at the pictures, I was having trouble locating anything. So that was too much fun. Thank you. And a big round of applause to everyone out there for playing and participating in the challenge, and for Louise taking us through the challenge. Some of those pictures were super difficult. And once again, it made me realize what amazing observational skills you and your team have, Louise. And now, my friends, it is the time you have all been waiting for. Yes, it is time to kick off the question and answer portion of our show. If you are watching online, send us your questions in the chat bar. We record them all as they're sent in, so please only send each question once. And teachers, please let us know who's asking the question so we can give your class a proper shout out. And if you're an on-screen guest, get ready with a nice loud voice. Yes, and I will tell you when it's your turn. And Louise, we're going to kick it off today with one of our virtual questions from YouTube. And we have a question from Vivian in Washington, D.C. And Vivian just wants to know, what are some of the coolest fossils you have found?
Okay, Vivian. Well, we found some amazing fossils, but some of the coolest fossils we found, let me give you an example. I think we've got a skull here. These are not real, by the way. I wouldn't be holding up a real skull. These are replicas. These are casts of what they might have looked like. So that is a skull of something called Homo erectus, and it belonged to a skeleton that was found on the east side of the west side, sorry, of Lake Turkana, and it is dated at 1.6 million years. And you can see it has teeth very like our own, and it was about 9 years old at the time that this ancestor died, and we can tell that because it hasn't got its third molar erupted in its line of teeth there. So this is a really exciting fossil because it was so complete. This is only the head of a complete skeleton that was found on the west side of Lake Turkana. And here's another skull. And this one doesn't look anything like us. If you feel the top of your head, you don't have this crest running down the top of it. And the reason that skull had this crest there, the sagittal crest, was so that a large muscle could come up through this little hole in the side, and it would have attached to the top of the skull, this sagittal crest. And it had such a big muscle because it has enormous teeth, and it must have been chewing some very coarse vegetation or grasses or something like that. So it needed a very powerful muscle to power that jaw. So this skull actually belongs to a hominin that at the time was called Zinjanthropus, and it was actually found at Olduvai Gorge in 1959 by my grandmother, Mary Leakey. And this skull is what put Africa on the map because it was dated at 1.75, nearly 1.8 million years. And clearly some very old fossils existed on the continent that predated humans. And so it meant that Africa was indeed a very good place to look for the ancestors of humans. So those two, I would think, are some of the coolest fossils that have been found in this part of the world. And I remember very clearly this skull being found because I was about your age. I was about 12, 13, maybe some of you a bit older when this fossil was found. And so it was really exciting to see this thing coming out of the ground.
The deal with fossils as well. And I'm looking at Yoshi from the Philippines. And Yoshi's super curious about the largest discovery or the largest fossil that you all have excavated so far.
So what's the largest fossil? It has to be a 4 million year old elephant skull that we found on the east side of Lake Turkana in 2013. And actually the tooth row was showing just the single tooth when it was found. And so we didn't know how much of the skull was going to be underground. And when we began to dig away at this thing, it honestly was the size of a small cow. It was actually enormous and very, very heavy. So once you've got a heavy fossil in the ground, you've got to work out how on earth you're going to lift it. And so we then had to dig underneath it and cover it in a plaster jacket. And then we had to actually roll it onto a stretcher, and then we lifted it up with a block and tackle and drove a car underneath it so that we could drive this thing out of the site. But that was probably the biggest fossil that we've actually pulled out of the ground at Lake Turkana, and it was just the skull. We didn't find any more of that fossil.
I'm seeing some tons of questions pop in from YouTube. And one that I think our audience is really interested in. Earl is asking, have you ever dug up a dinosaur skeleton?
So interestingly, Lake Turkana, most of the fossils that come from the sediments and the deposits at Lake Turkana actually post-date. They are younger than those that dinosaurs lived in, except on the very, very northwest of Lake Turkana. There's a small range of hills there called the Lapua Range, and we've got some dinosaur fossils in there that are dated at around about 85 million years. But most of the things that we work in are around about 4 to 1 million years, the sites that I'm interested in. So I don't dig up dinosaur fossils very often, but there are people who are interested in those dinosaurs and they work those hills. So I've seen those fossils in the field, but it's not my team that digs them up because another project is responsible for working those dinosaur deposits at Lake Turkana. Now, they're not nice, big, complete skeletons like you see in parts of America. They are usually sort of tumbled leg bones and things that have sort of been washed down old riverbeds. So they're not very complete skeletons like you've seen in some of the pictures, but we do have some dinosaurs after all. But dinosaurs, as some of you know, went extinct at 65 million years. And so the deposits that we're looking in that are much later than that, obviously we're not going to find dinosaurs in. So we find fossils of other things mostly and not dinosaurs. But other fossils are cool. They're still exciting.
Yes, agreed. Such a wonderful question. And a couple questions on YouTube to kind of piggyback on that, Louise. Cheryl is curious, after using these tools and after going through the excavations, how do you put the small pieces of bones together if they are separated? And then Tahira asked kind of a follow-up question. Do you use virtual simulations to put the pieces together?
Oh, very good. So it's like doing a 3D jigsaw puzzle. So when you find these pieces and you see there's a fresh break, and certain bits of fossil have little, very distinctive color or texture. So you then try to find the matching side in all the fragments that you've pulled out so that you can then try to stick it together. You can 3D scan these fossils and the fragments, and then you could actually possibly ask sort of machine learning or use different algorithms to try to fit those pieces together. But people have experimented with that, but it hasn't been particularly successful. It's more successful when, say, you have a stone tool and you know that those things are exactly that fossil or that stone, and you can then actually see where they would fit together. But it's not yet been applied very successfully. But no doubt, as that improves, that this might actually become a useful tool for us. We do put our fossils through high resolution scanners, because what you can do then is you can get an idea of what the inside of these things look like. So you have a skull, if you put it through a medical scanner, you can look at the shape of the ear, right? The semicircular canal, you could see teeth that haven't erupted yet. And so you can actually double the size of your fossil in terms of information, just because you've got structures of bits that aren't visible to the eye from the outside. And so increasingly we use micro CT scanners to actually get additional information. And then you're in a world of using 3D images to then try and assemble and make things, put images together so that you can build out what those things look like and then 3D print them. So you can then 3D print a particular tooth and then study it more carefully that way. So 3D printing is an important technology that more and more people are using once you've got digital replicas or 3D scans of the fossils themselves.
There are so many questions coming in, Louise, that are so good. I have another one from YouTube that I think a lot of our viewers are probably wondering, from Larcy and Ronald. They're curious, how do you know what you find is indeed a fossil and not just an ordinary bone or a rock?
Okay, so every little bit of fossil that you find, it's got texture and color. It's usually got little bits of you can see vein marks, or you can see bone where it's broken. It doesn't look anything like a rock. So it's actually quite easy to differentiate between a fossil and, say, a rock or a stone tool. It's much harder to differentiate a stone tool from a rock, right? Because sometimes rocks look quite like stone tools, but actually stone tools have to have been made and one rock bashed onto another rock to remove a flake, and then that's considered a worked piece of rock. It's a tool. So I must say I'm not so good at finding tools as I am finding fossils. But to be honest, the teams of fossil hunters that I work with are a lot better at finding fossils than I am. Let's put it that way. I'm much better at collecting things than finding them. I used to be better at that, but not anymore.
And we have so many questions that I wish we could go all day, but unfortunately we're down to the end of the show and we have time for one final question. So Louise, is there any last message you would like to give the young explorers out there before we end this session today?
Yeah, I think keep your eyes open and go out there and see what you can find. You never know. If you find yourself in a place that might have fossils, anyone can actually find these things. And if it's something that you think is important, do tell us or tell somebody who might know what you found, because it could be significant. And the other thing really is, if you find these fossils and you see they belong to animals that long went extinct, you got to stop and ask about our future on the planet and think about how we need to actually take care of all the different animals that we live alongside, and have to be terribly careful not to drive other species to extinction because of our own actions. So we need to be responsible global citizens and really not only look out for things that are on the landscape and try and preserve them and collect them responsibly, but also take care of all the other animals and plants and the natural ecosystems that we exist with today, because there's no certainty that that's going to be here forever. Because when you work on fossils, you realize that not many things are here forever. A lot of things actually go extinct. So we all have to do our bit to make sure that we save what we have for future generations.
Wonderful advice, Louise. And you heard that, friends. Keep your eyes open, be responsible global citizens. Love that. And thank you again to Louise for taking the time to be with us today. And thank you so much to the students for your thoughtful questions, and for the teachers joining us around the globe. And to the teachers, we'd love to see your students' work. If your class is inspired to create something today or take action after one of our Explorer Classroom events, please share it with us by emailing explorerclassroom@ngs.org. We have a very exciting Explorer Classroom season planned, so please register your classes at natgeoed.org/Explorer Classroom. When you register, you can request a chance to be featured up here on screen with us. And join us next week with Explorer Elizabeth Henschel to explore the discovery of a new species of fish in the Atlantic Ocean. Have a great day, everyone. Stay curious and keep exploring. We'll see you next time.